Scientists have detected a significant solar flare, and as a result, Earth is expected to experience a geomagnetic storm on Thursday. On Monday, the Sun emitted a mass of plasma and magnetic fluctuations called a coronal mass ejection. A portion of this ejection is expected to reach our location by Thursday. According to NASA modeling, Earth is anticipated to experience a solar storm this week, which is projected to be a minor impact. This occurrence follows a solar flare and radiation storm emitted by the Sun yesterday. According to the National Oceanic and Atmospheric Administration, NOAA, Space Weather Prediction Center, the emissions originated from a sizable sunspot known as Active Region, AR, 3363. This sunspot also emitted a less intense flare on Sunday. The X-ray flare, classified as M57, reached its zenith at approximately 2:06 p.m. EST on Monday. Subsequently, the solar radiation storm commenced roughly 2 hours later and extended into Tuesday. As per NOAA, these two space weather events result in a decline in high-frequency radio signals on the sun-facing side of Earth and in the polar regions. WhatsApp has become a significant platform for political discussions and communication. People use it to share and exchange political news, opinions, and updates. It has provided a space for political activism and mobilization, allowing individuals to organize and coordinate political actions. However, it also has its drawbacks, as the spread of misinformation and the potential for manipulation are concerns. Overall, WhatsApp has had a profound impact on the political landscape, shaping the way people engage with politics and influencing public discourse. Scientists have recently observed a significant solar flare, indicating that the Earth will experience a geomagnetic storm. Yesterday, the Sun discharged a collection of plasma and magnetic disturbances called a coronal mass ejection, which is expected to reach our location on Thursday. According to NASA's modeling, Earth is expected to experience a solar storm this week. This occurrence follows a solar flare and subsequent radiation storm that originated from the Sun. According to the National Oceanic and Atmospheric Administration, NOAA, Space Weather Prediction Center, the emissions originated from a sizable sunspot known as Active Region, AR, 3363. This sunspot also emitted a less intense flare on Sunday. Yesterday, at approximately 2:06 p.m. ET, the X-ray flare, classified as M57, reached its highest intensity. Subsequently, the solar radiation storm commenced roughly 2 hours later and extended into the present day. NOAA states that these space weather events result in a decline in high-frequency radio signals on the sun-facing side of Earth and in the polar regions. The Solar and Heliospheric Observatory, SOHO, by NASA has detected a coronal mass ejection, CME, emanating from AR 3363. This CME consists of charged particles and electromagnetic fluctuations and is anticipated to arrive by Thursday. Astronomer Dr. Tony Phillips of spaceweather.com expressed anticipation for Monday's solar flares, specifically noting the occurrence of a substantial solar flare from sunspot AR 3363. This flare was a lengthy M6 class event that took place in the early hours of July 18th. The explosion near the Sun's southwest edge was captured by NASA's Solar Dynamics Observatory. Energetic protons propelled by the flare have arrived at Earth and are currently bombarding the upper atmosphere, known as a radiation storm. Based on information obtained from NOAA's GOES-16 satellite, the event is classified as Category S2. Solar flares are classified into 5 categories according to their flux: A, B, C, M, and X, with X being the most powerful. They are also assigned a numerical value indicating their size. According to Dr. Phillips, the explosion, while not classified as X-class, exceeded the power of numerous X-flares due to its prolonged duration. For over an hour, the flare emitted X-rays at levels exceeding M5, and for nearly 4 hours it exceeded M11. With ample time, it managed to expel a significant coronal mass ejection from the Sun's atmosphere. In fact, the SOHO coronagraphs have observed a luminous CME originating from the explosion point. Coronal mass ejections originate from the Sun's lower corona when highly twisted magnetic field structures reach a breaking point and reconfigure into less tense arrangements. During this process, there is an abrupt discharge of electromagnetic energy, resulting in a solar flare, along with the release of plasma that forms the CME. According to NASA's projections, although not directly targeted at our planet, the recent CME does possess a component that is directed towards Earth and may impact us as soon as Thursday. Dr. Phillips states that the arrival of the CME may trigger G1 or G2 class geomagnetic storms, possibly G3. Solar storms of these types have the ability to cause minor power grid disturbances, impact satellite operations, and create intermittent issues with satellite and low-frequency radio navigation. In September 1859, a coronal mass ejection resulted in the strongest ever geomagnetic storm. This particular event is commonly known as the Carrington event among scientists. The storm disrupted telegraph networks in Europe and North America, including the newly installed transatlantic connection. The space weather event led to the creation of electric currents in cables, resulting in sparking of telegraph pylons, electric shocks for operators, and complete failure of certain lines. Despite their power being cut, some connections were discovered to continue functioning due to the immense electrical currents generated by the storm. During the SIGCOM 2021 conference, it was revealed that a solar storm similar to the Carrington event could severely impact the internet for an extended period. In contrast to telegraph lines during the Victorian era, fiber optic cables that compose the internet's infrastructure are impervious to electromagnetic disturbances triggered by solar storms. Contrary to that, the signal boosters placed along undersea cables to sustain long-distance connections do not share the same characteristic. Due to their subaquatic nature, these long-distance cables are not only more susceptible to the effects of space weather, but they are also inherently more challenging to reach for maintenance. According to astrophysicists, there is a 6-12% likelihood of a solar storm occurring within the next decade that could potentially cause severe disruption to modern society. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.